Hi, everyone. This is Rob Gray from ASU and the Perception Action Podcast, back with another article review. In this episode, I want to get into the topic of injury and the role, something I've covered before, the role of variability in injury. And, this is also we're going to see we're going to get into the topic of redundancy and degeneracy, right? Because we're going to talk a little bit about individual differences and how people respond to load. And what we're talking about here is this article here that got published in Scientific Reports, Magnitude and Variability of Individual Elbow Load in Repetitive Baseball Pitching. Okay, so we're talking about baseball pitching here. And as I've covered many times on the podcast, you can go back and listen to my episode I did reviewing Jeff Passan's book, The Arm, right? Baseball pitching, there's kind of been an epidemic, and this year kind of it increased again in UCL injuries. So the UCL is a ligament basically that holds the upper bone in your arm to the lower bone, right? And what happens to a lot of pitchers is that gets torn, and there's a special type of surgery called Tommy John surgery, named after the first pitcher that ever had it, where they take a ligament from another part of your body, usually your leg, and they replace it, right? And it's very, very successful. Pitchers come back a very high rate, oftentimes any very stronger. Sometimes pitchers have to have this done twice. The most famous example right now, Shohei Ohtani, right? He's just went undergo his second UCL surgery. That's a little bit, less successful, but we'll see what happens with him. But basically, the rise in the number of UCL surgeries and injuries has basically exactly followed the rise in fastball velocity, right? People are trying to throw harder and harder. They're placing more and more load on their elbow. They're getting hurt, right? So we want to understand how can we mitigate, right? And what the traditional way we've been mitigating that is through, you know, the load. Like, so I always talk about there's three pillars of injury: load, frequency, and the new one, variability. Load, right? We're trying to, keep the number of pitches down so they don't throw, and maybe how often they throw, how many days rest they have between, which is frequency. So this study is going to dig into some of these, right? So they're talking about, the first points they raise, mechanical load with it throwing harder seems to be um, related to the injuries. What they're going to look at, focus on here, is the torque on the elbow, right? As the proxy for loading your UCL ligament, right? It's not exact, perfectly a match, but it's close as we got, right? So they're going to measure torque, right? And baseball pitching, the amount you throw and how this torque, the amount of this torque. So torque is a rotational force. The amount that changes as you go through the game, right, seems to be an important relationship to injury, right? And so we can think about how those things might be related, right? So kind of the traditional view, like the traditional view of how you perform a skill, where a pitcher is trying to repeat their delivery every time, right? The old story, right? As you go through a game, you get more and more fatigued. You can't produce the same kinematics, right? So you can't repeat your delivery. You get a little sloppy in your mechanics, right? Your variability in your delivery goes up. That increases the force. You get hurt, right? Um, what they and there's some evidence there's not a lot of evidence to actually support that. Although in this paper, this group actually found that if you measure within a pitcher, the variability of this force, the torque force, is a predictor of injury. So let's take a step back and think about that for a second, right? So when we talk about variability here, right, it's important to think about what Bernstein's called essential variables or elemental variables and outcome variables, right? So torque and force is probably closer to an outcome variable, right? You want the force you produce on your elbow to be fairly consistent, right? The forces you're producing to be fairly consistent. You don't want to have, like, in the 77th pitch of a game, suddenly a huge increase in force, right? That's probably not going to be healthy, right? So we probably don't want a lot of variability in that. What we do want, if you believe in repetition without repetition in Bernstein's eye, is the variability in how you produce that force, right? The muscle contractions, which body parts involved, how they're working together, the synergies, right? So remember that when we're talking about variability of that torque force. We're not talking about variability in the kinematics, the actual movement that produced that force, right? So that's the main idea, right? One of the ideas we expect to see increase in variability as we go up, as we pitch longer and longer, more force, get hurt, right? That's kind of the standard view. The newer view we're taking about is that the variability might be a protective mechanism, right? So variability in the kinematics, which wasn't actually measured here, might in producing the same force might be actually help you from getting injury, right? But importantly, what they're going to do in this, they're going to measure across a long series of pitches. Okay, so they're going to look at on the individual level the load, that torque load on the elbow, and they're going to look at a few other body parts as they pitch. They're going to have them blocks of 10. They're going to keep pitching and pitching and pitching, seeing how that changes, right? Um, what they're expecting, right? They're not going to expect to see that. As I said, on a group level, they haven't really found that force goes up, right? And we'll see why in a second. They're also going to use EMG to measure the activation of muscles, supporting muscles, the flexor pronator mass, the biceps, that triceps that support the elbow during pitching. Right. So they're going to measure these things as the pitcher throws more and more pitches to see how they change. Right. So they had 15 baseball pitchers. Mean age was 24 and a half years. These were not super high level pitchers. They were mostly recreational, some of them playing at the highest level from the Netherlands. They're using an OptiTrack system to measure the forces and the kinematics. As I said, they don't really talk about how the kinematics change or measure anything like synergies, like I would like to see them do. And they're measuring EMG as they go. And the EMG, so actually after they're pouring, as I said, they're doing fastballs, throwing as hard as they can, full effort, 10 blocks of time, little rest, another 10. So sort of like a baseball game, right? You pitch an inning, rest for a while, and go back out. And they're rating their fatigue on a scale as they go. The EMG was for they were measuring electrodes on the biceps, the flexor pronator mass, and the triceps. So they're measuring how much activation is in the different muscles. Okay. So that's the basic design. So they want to look at how the loading on the muscles, the forces, and the variability in those things change as the pitcher goes further and further, right? To see if they change as they get more and more fatigued, right, with pitching longer and longer, which obviously is extremely relevant to understanding injury. For this, they kind of used a rolling window kind of approach. So they took 10 pitches at a time. They measured the magnitude of the force and the variability of the force in that window, and then they moved the window along, right, as you were going. Right? So that's kind of the approach. And they used kind of a modeling, which if you're really interested, you could read the paper. But trust me, that's the basic design. Okay. So what did they find? Well, the first thing they found was there was no change in velocity, right? So as they kept pitching, they kept more and more pitches. They kept their velocity relatively the same. So they're keeping the outcome, right? The outcome variable is consistent, right? They also found over time, this is on the group level, there was no significant changes in either the variability or the magnitude of force as that window got farther, right? So the 10 pitch window from 80 to 90 was no different from 1 to 10, right? The amount of force. So that kind of goes against the traditional argument, right? You're losing your mechanics, you're lost your delivery, your repeatable delivery, and that's causing more forces, and that's why you're getting hurt, right? So they did not find that at all in the group level. What they found was extreme individual differences. So what they found, if you look at the magnitude, and if you're watching the video here, you can see there's graphs with the different colors. So if you look at the magnitude of the torque force on your elbow as a function of the number of pitch number, for some people that force goes up, like the traditional acceleration. Some people goes up a little, some people goes up a lot, some people stays the same, some people goes down. So you got possibly particularly every possible outcome if you look at individual level. Same with the variability. Some people's variability in the force went up, some went down, some stayed the same. So there's no consistent pattern in how these things are changing, right, as they go across the number of pitches. Also, really importantly, if you look at the muscle activation, so which muscles are being used when you're throwing, the flexor pronator mass and the bicep, you get the exact same pattern. For some pitchers, that goes up, the activity, some goes down, some stays the same, right? For me, this is the hallmark of redundancy, right? There's lots of different ways you can produce that velocity in a fastball. Well, not lots of different ways because this is a highly constrained, right, action. I always, to order to throw, there's only so many ways you can make a ball go 95 miles an hour, right? So but there is still redundancy in the system. And you can see it here, right? Some people are, as they go along, they're using more of their bicep. Some people are using less of their bicep. Some people are using more of the flexator protein mass. Some people are using less as they go along. Remember, velocity did not significantly change. So they're keeping, this is a classic repetition without repetition. They're repeating the outcome, but not by repeating the movement using the same muscles as they're going along. Some people seem to relatively, but across individuals, there's huge differences as we go, right? So I think that's important. That's a really important finding to see. There's no simple pattern here. There's no simple explanation for injury. That's why we can't predict it at all, right? With any success, right? We can't predict it with any because there's so, your a body like redundancy is like a blessing and a curse, right? It's a blessing because it gives you such an amazing system that can produce outcomes in so many different ways, which has, makes you adaptable, makes you injury prevention, does all these things. But at the same time, to understand it is very difficult, right? And this is something we've seen, I talked about when I had Wes on talking about biomechanics of lifting. Right? We don't even know, like, muscles not only change the amount they're doing, they completely change the role, right? So you have a muscle that we consider to be a support muscle. Suddenly, in another situation, it's totally different role. So redundancy is an amazing thing, right? Your body has all these different parts it can put together in these soft assemblies to achieve lots of different things, right? So I think, like I said, I didn't expect to see the typical pattern of variability helping prevent injury like we saw before. We're not measuring injury here anyway, but remember, we're measuring variability in torque, right? Which is, I think, is closer to an outcome variable. That's something you want to be fairly consistent, right? The force, right? Not the details of how you produce that force. Okay. So, were significant differences among pitchers in the relationship with the elbow within individual load, magnitude, variability, activity in the different muscles. Um, Again, the authors say this is why you don't find any group effect, right? They're all different patterns. There's no overall pattern. Okay. It's really important they emphasize to measure within an individual, right? We need to track individuals. This is something that's a common theme of my research. To truly understand skill acquisition and skill, we have to look at individuals, right? People aren't the same. There's very few patterns that hold across large numbers. We need to. Why do some pitchers show an increase in elbow within load magnitude and variability load, and others a decrease? Right? There's something going on here, right? For some people, the variability in the loading seems to change. That seems to go up. Others it goes down. Others it seems the same. So again, we're not seeing, although we tend to have these simple stories, and I do them too, right? Variability prevents injury, right? It's not that simple, right? Especially this is a really good case, I think. Yes, variability in what, right? Variability in the outcome, variability in the elemental variables, the movements themselves, right? So you really need to consider what you're talking about here. But I think this is a really good paper. I think it demonstrates for injury prevention, we need to understand why one pitchers show a decrease or change within individual load and others don't, right? We need to understand what is the mechanism here? How is this relating? And I think that's kind of, as I said, the redundancy system we have built in can compensate in a lot of different ways. And we need to think about on an individual level how an individual pitcher is compensating. So overall, I think this is a really interesting paper. It's kind of adding to the story of variability, kind of in a more complex way. And again, emphasizing the point of individual differences. There's so many when we talk about skill, right? So I think that's really, really important to consider. Okay, that's it. Cheers for now, and keep them coupled.